All right, as we begin this next chapter, it's good just to get a general overview of what it's all about. And this chapter is about oxidation and reduction of organic molecules. So it's going to look a little bit different than oxidation and reduction in general chemistry, which is probably the last time that you've seen oxidation and reduction. In general chemistry, they were really focused on the electron, so oxidation is loss, reduction is gain of electrons. But in organic chemistry, we focus a lot more on the new bonds that are formed in the reaction. So this first video about this is just an overview about what oxidation and reduction are. So oxidation is increased bonds to increase carbon-oxygen, carbon-nitrogen, or carbon-halogen bonds. And it can also be characterized as oxidation if somehow you are decreasing the number of CH bonds. Reduction is a decreased number, so it's the exact opposite of oxidation. So now we're decreasing the number of CO, CN, or CX bonds. And in reduction, we are also increasing the number of CH bonds. So that's a general kind of overview. And this is on page 1 of your notes from this chapter. But really what we see in the two different kind of figures on that first page is that the top one is all about redox with heteroatoms. So we'll write heteroatoms in here. So again, what are heteroatoms? They're any atom that is not carbon or hydrogen. And really specifically with oxidation, we're talking about carbon-oxygen, carbon-nitrogen, or carbon-halogen bonds. So this first figure just kind of shows this would be the most reduced form of carbon. It has 4 hydrogens. It doesn't have any oxygens. And as we oxidize, each step of oxidation adds 1 oxygen, 1 nitrogen, or 1 halogen to the molecule. So one step of oxidation would make a new CO bond. 2 steps of oxidation would make a CO double bond. A third set of oxidation would be a third CO bond, and then the last oxidation step would oxidize to carbon dioxide, which would be fully oxidizing that carbon atom. And reduction is just the opposite. We're adding a CH bond each time as we're going right to left. So this is redox with heteroatoms. We could sub in a nitrogen for that or a halogen. But we can also have reduction/oxidation reactions with multiple bonds. So what I would call that is unsaturation. So a molecule is completely saturated if it has all of the hydrogens that it can have. If it is unsaturated, that means it has double or triple bonds. So redox with unsaturation would just refer to changing from a triple bond to a double bond to a single bond. We learned all about triple bonds and how to synthesize them in the alkyne chapter. And in this chapter, we're going to learn how we can reduce them to alkenes or reduce them all the way to alkanes. And as I said, reduce them. We can see that we are adding hydrogens to the structure when we go from alkyne to alkene. We added 2 hydrogens. And what is reduction characterized? The second point is an increased number of CH bonds. So we reduced it there. When we add 2 more hydrogens to it, we've fully reduced it to the alkane. So the opposite way would be just oxidizing the molecule. We're going to learn about that as well this chapter. But this is just a general overview of what oxidation and reduction are. The rest of the chapter is really going to be focused on the specific reagents that allow us to do this and how those mechanisms work and all those things. So look forward to that. Yay!